Look closely at this robotic face. As the servos shift through different expressions, the system generates subtitles for everything it hears and says. This is the practical execution of a graduation thesis project, explicitly designed to assist students with language learning. The end goal is to take a standard Raspberry Pi 4 and transform it into an interactive, real-time English tutor using large language models and active facial recognition. To start this build, you need the Raspberry Pi 4, an Arduino Mega, a Pi camera module 3, a USB microphone, and Python 3.11. By assembling these off-the-shelf components, you create a locally hosted educational tool right on your desk. This block diagram breaks down the architecture. The Raspberry Pi 4 serves as the central brain, handling all perception and physical action commands. To the left, the USB microphone and Pi camera feed raw audio and video directly into that central processing unit. You must first flash the 64-bit version of the Raspberry Pi OS, avoiding the legacy 32-bit version. The 64-bit architecture is strictly required to run modern machine learning libraries, specifically the faster Whisper transcription model. Establishing the correct operating system prevents memory bottlenecks when the hardware processes complex speech data later. This documentation outlines the first stage of our conversational pipeline. The microphone captures raw audio at 16 kHz. Notice the voice activity detection step here. It filters out background noise, so the system only transcribes actual speech, keeping the CPU from overloading. Transcribed text routes through the OpenRouter API to Qwen3 Coder, generating responses that fit the lesson criteria. Since API timeouts happen, code a fallback option like Mistral 7B. This ensures the conversation doesn't freeze if the primary server drops the connection. The LLM's text response comes back to the Pi, where the local Piper text-to-speech engine converts it into natural-sounding audio. If configured correctly, this entire loop, from hearing the student to speaking a reply, takes about 12 to 18 seconds. This pipeline takes raw, noisy room audio and outputs an intelligent, context-aware spoken response. This system flowchart shows how the interaction begins. The Pi uses facial recognition immediately to identify the user and determine their access level. In the tkinter GUI, type the student's name and initiate the capture sequence. The camera will take 50 distinct images of their face. Train the LBPH model next. You can verify the process is working by watching the terminal output as it saves each image path sequentially. Returning to the process flow, a successful face match bypasses basic chat mode and routes the user directly into the personalized English teacher module. Locking the login behind facial recognition allows the software to pull specific user data, turning a generic chatbot into an individualized instructor. Once a student is identified, TinyDB takes over, retrieving their specific profile and history from a local JSON file. This interface shows a new user's dashboard. Notice the reading, grammar, and vocabulary progress bars all start at 0. The PCA9685 driver translates those commands, actuating the 3D printed jaw servos in perfect rhythm with the synthesized voice. OpenCV and MediaPipe track the user's face, driving the neck servos to ensure the robot maintains eye contact. Aligning these precise servo movements with the speech output bridges the gap between code and an interactive tutor. The integration is complete. Faster Whisper, OpenRouter LLMs, Piper TTS, and TinyDB are operating as a single unified system. The robot actively evaluates spoken input, enforces grammar rules, and tracks long-term progress tied directly to the user's face. From here, you can edit the JSON database to map out more advanced English courses, or write new modules to teach entirely different languages. You have successfully assembled an advanced, locally hosted AI educational tool. Lingo proves that sophisticated, adaptive learning hardware can be built entirely from the desktop up.